Good afternoon, students. The first problem I'd like to look at, the first group of problems is operations with fractions, and we'll start by looking at addition of fractions. If I have two fractions which have got exactly the same denominator, there is no difficulty in adding those two fractions together. So if I have 3/8 plus 1/8, I can simply add the two numerators together and I have 4/8. If I need a diagrammatic representation to help understand that, I can think of, say for example, a pizza, which I have broken up into 8 equal parts. So that's 4 equal parts, 8 equal parts. So if I had 3/8 for pizza, let's shade that amount there. That's 1/8 there, that's another 8, and this is another 8. And then I wanted to add on one more 8. Okay, so plus one more 8, which would be here. We can see that now we have got 4/8. But our diagram also indicates that we can look at our 4/8 in another way. The 4/8 is in fact going to be equal to the same as half of my pizza. And we have been looking at equivalent fractions so far, and we know that fractions are equivalent whenever the denominator and the numerator can be divided by the same, divided or multiplied by the same number. So in this case here, we're dividing the denominator by 4 and the numerator by 4, and so 4/8 is equivalent to 1/2. We can see our representation. So that's addition of fractions when we have the same denominator. However, if we are looking at addition of fractions when we do not have the same denominator, we can use equivalent fractions to help us. So let's consider what it would happen if we had 3/8 being added to 1/4. Now, 3/8 is made up of 3 pieces which are 1/8 of a whole, and this is one part out of 4, where a whole has been divided up into 4 parts. So the fractions are not the same size. So if we draw a picture here, we can see again that the 3/8 we would have to divide, say for example, a pizza up into 8 equal parts, and we are choosing 3 of those. 1/8, there's another 8, there's another 8. So that would be the amount which would be equal to 3/8. Now, 1/4, we need to understand 1/4 as being, okay, we've only divided the whole up into 4 parts and we're choosing one of them. So that's 1/4. So if I want to add 8s to 1/4, we can't do that because the pieces are not the same size. So what we need to do is to make the pieces the same size. And we can do that by recognizing that the quarter here could be thought of as in fact being 1/8 plus 1/8, which is equal to 2/8. So to do this problem, we simply say that would be 3/8 plus the equivalent fraction 2/8. And so now we would see that the answer would be equal to 5/8. Now this is the critical step. To understand that the 1/4 and the 2/8 are the same number, they are simply equivalent fractions. And so we don't need to do a diagram for our problems. If we had, for example, another problem where we had 2/6 plus 1/3, again, we can see that we're looking at different size parts. So we need to make the parts the same size, which means that the denominators will have to be the same size. Well, I can make the denominator 3 to 6 by multiplying by 2. So that would be equal to 2/6. Now notice I didn't change that fraction, but the 1/3, I'm going to change that to 2/6. How did I do that? Because I've multiplied the denominator by 2 and the numerator has been multiplied by 2. So the answer to that would be 4/6. But again, we need to use our equivalent fractions to recognise that 4/6 is going to be equal to 2/3. Why? Because we can divide the denominator by 2 and we can divide the numerator by 2. So 4 out of 6 parts, 4 out of 6 equal parts would be the same as 2/3. And if we wanted just a reminder of what that might look like, okay, think again of our pizza, where instead of dividing it up into 8 parts, we now divide it up into 3 parts for each half. So 4/6 would be equal to 1/6, 1/6, 1/6, 1/6, 1/6. Sorry, that's 5/6. So there's our 4/6. Now 4/6, we can see that is in fact going to be equal to, if we combine the two 1/6 parts together, we have that part, that part, and that part, where each one of them is 1/3. So 4/6 is going to be 1/3 plus another third. So hence the equivalent fraction 2/3. Let's look at another problem where we're adding mixed numbers. Now there's more than one way to add fractions with mixed numbers. For example, we can add the whole parts first and then we can add the fractional part. So one way to do this would be to simply say, well, I've got 5 whole parts and 4 whole parts. That would be equal to 9 plus 1/3 plus 1/6. And then if we look at the 1/3 and the 1/6, we can see that we can only add those together if we make the denominators the same. So we can make the denominators the same by writing an equivalent fraction for 1/3 as being 2/6. How do we change that? We simply multiplied the denominator by 2, so therefore the numerator had to be multiplied by 2. So that would be equal to 9 and 3/6. And of course, 3/6, we can see that there is a common factor in both the numerator and the denominator. So that would become 9/1/2, simply by recognising the fact that we can divide the 3 by 3 and we can divide the 6 by 3. So that 3/6 becomes 9.5. So a simple problem. However, another way of doing the same problem, again, if we look at the number 5 and 1/3, add 4 and 1/6, we can also do this by converting these to improper fractions. So 5 and 1/3 is going to, each of those 5 parts will be made up of 3/3. So the number of parts we would have would be 3 times 5 is 15 plus 1 is 16 over 3 third parts. And likewise, 4 and 1/6 would be equal to 6 times 4, which is 24, plus 1 is 25, sixth parts. So again, we can't add those fractions because the parts are not the same size, so we need to be looking at the same fraction. So we'll need to convert this first fraction here to an equivalent fraction with a denominator of 6. So if I do that, I've multiplied by 2. Multiplying 16 by 2, because I've multiplied the 3 by 2, is going to make that equal to 32 plus 25/6. So all together now we would have 7, 2 and 3 make 5, 57/6 equal parts. So how many wholes do I have? Well, every 6 will be a whole. So 6 into 57, 6 tens are 60, 9 sixes are 54. So 9 will make for 54 of those parts, and we will have 3 6 left over. And we simply just need to remember that 3/6 is going to be equal to the same as 1/2 because it's the equivalent fraction when I divide by 2, top and bottom. So our problem is solved. Notice the features of the problem. We should always be working down the page, making sure that each step is equal to the one before it.